Hello everybody and welcome back. We're looking at question number 19 in this video. Question 19 from our grade 10 multiple choice contest from 2007. In the diagram, 4 points have coordinates 0, 1, 1, 3, 5, 2, and 4, 0. What is the area of quadrilateral A, B, C, D? What could we do? I think, let's see, add 1, add 2, and then from D to C, add 1 and add 2. This is, this looks like it's going to be a parallelogram. Oh, yeah, I think it is a parallelogram. I don't know if that particularly helps me. It's just something I noticed. What could I do? I think easiest thing to do, it's slanty. If one of its sides were flat against the x-axis, I think we'd be fine. So what instead I'm going to do is I'm going to encase it in a rectangle. A rectangle whose area I can work out. You know, it'll have a height of the difference between the heights of B and D, and a length of which is the distance between the x-coordinates of A and C. But then I get all these little right angles here. And I can get these triangles, and I just chop away these triangles from the area of the rectangle, and I should have what's left. So I've got my plan of attack. Let's get to it. Put A over here, B over here. Doesn't really matter that it's a parallelogram, I don't think. Alright, so we'll use orange, I guess. Alright. So the area we want, the area in here is what we get when we take the orange rectangle and we subtract off each of these smaller triangles. I'm going to label them as the 4 blue triangles. They are not all the same size, so don't get fooled there. But this is just my plan of attack. Alright, so B has a height of, what was it, 3? Yeah, B has a height of 3, D has a height of 0, so the difference here is a height of 3. Okay, so my rectangle is a 3 by something. A goes from 0, 1, all the way over here to 5, 2. So the difference between 0 and 5, it's going to be a length of 5. So 3 times 5, total area of 15 for our orange rectangle. And now the specific coordinates are going to come into play. Because if I'm going to figure out the area of these right angle triangles, I'm going to need these side lengths, these legs of the triangle. What was B? B is 1, 3, isn't it? We'll just double check the coordinates really quick. 0, 1, 1, 3. Yeah, okay, everything looks good. So to get over to B, I go over by 1 and up by 2. To go from A over to D, we go over by 4 and down by 1. To go from D up to C, we go over by 1 and up by 2. And to go from B to C, we go over by 4 and down by 1. Okay, so I do notice that we do have 2 congruent triangles, but that's just because, 2 congruent there, and these 2 are congruent here. 2 purple triangles. They're the same, which comes from the fact that we're dealing with a parallelogram. But it doesn't really matter, so this one here is 1/2 base times height. This one here, 1/2 base times height. 1/2 base times height. And here, 1/2 base times height. And we add these up, and this is the area we need to take away to get our red area, the area of this parallelogram. So 1/2 of 2 is 1. 1/2 of 4 is 2. All Alright, so the extra little right angle triangles make up an area of 6. So the area of ABCD is the 15 for the big orange rectangle, the rectangle that encases everything, minus 6 for the triangles that we take away, the green and purple triangles, and that gives us a final answer of 9, and that is A. So there we go, we bubble in A, and that finishes up question number 19. I will see you guys in the next video for question 20. Let's flip the page to prepare for that, and I will see you guys for that in the next video. Until then, take care.